Let's talk about division with radicals and rationalizing denominators. We should never leave a radical in the denominator of a fraction. To get rid of it, we do a process called rationalizing. There are two different scenarios that could happen. The first case, we could have one term on the bottom, a monomial, or the second case, we could have two terms in the bottom, a binomial. Let's look first at just one term in the bottom, something like 3 over the square root of 2. We've seen in the past that with square roots, if we multiply it by itself, then the radical will go away. So let's multiply the radical by itself for this one. Now, anything we do to the bottom of a fraction, we must also do the same thing to the top of the fraction in order to keep an equivalent expression. So when I choose to multiply by square root of 2 on the bottom, I also have to do it to the top. On the top, 3 times the square root of 2, we can't do any better than just saying 3 square root of 2. On the bottom, square root of 2 times square root of 2, since it's exactly the same, gives me just the radicand as the result, so just 2 on the bottom. I should always look to see if this will reduce in any way. This one does not, so there is our answer. Now, this always works with square roots, but it may not always be the best way to do it with a square root. For instance, on the next one, 3 over the square root of 20. While it's true that we could multiply both top and bottom by square root of 20, this will end up giving us an enormous amount of simplifying. Since square root of 20 is not in its simplest form, we would have to simplify that on the top of the fraction, and then there would be some canceling with the bottom. So while it works to multiply by square root of 20, let's see if we can find a better way. What could I multiply 20 by in order to make it into a perfect square? If we multiply 20 by 5, 5 times 20 is 100, and 100 is a perfect square. So let's multiply both parts of our fraction, top and bottom, by square root of 5. On the top, 3 times the square root of 5 is just 3 square root of 5. On the bottom, square root of 20 times square root of 5 is square root of 100. The whole purpose of doing this is that square root of 100 can be simplified to be just 10. No simplifying on top, no canceling with this one, so our answer is 3 square root of 5 over 10. Now, this method is necessary for us to do if we have something other than a square root. For instance, with the one here, 3 over the cube root of 2. If we chose to multiply both the top and bottom by cube root of 2, this wouldn't help any. We would end up with cube root of 4 on the bottom, and the cube root of 4 won't simplify. So I've got to think of something to do here to the bottom that'll turn it into a perfect cube. If I multiply both top and bottom by the cube root of 4, now we can create our perfect cube. The cube root of 2 times the cube root of 4 gives me the cube root of 8, which simplifies nicely to be just 2. I had to multiply both top and bottom by the same thing to keep an equivalent expression, and on the top, 3 times the cube root of 4, we'll just call that 3 cube root of 4. So our answer, again, since we can't simplify, 3 cube root of 4 over 2. Well, what if we have two terms in the bottom, a binomial like the one here? With a binomial, we can get rid of the radicals by multiplying by the conjugate. Remember that the conjugate is the exact same stuff, just the opposite sign in the middle. So the conjugate for square root of 5 minus square root of 2 is the square root of 5 plus the square root of 2. If I'm going to multiply by that on the bottom, I have to also multiply by it on the top. Now, let's leave the top part unmultiplied in case there's some simplifying at the end. So let's just call it 5 times square root of 5 plus square root of 2 in parentheses. On the bottom, the first terms together, square root of 5 times square root of 5 gives me 5. No need to do the OI part since this is a sum times a difference, conjugates. And then the back part, the last terms, minus square root of 2 times plus square root of 2 gives us a minus 2. Well, 5 minus 2 with no radicals can be combined. 5 minus 2 gives me 3. There's not any canceling that can be done, so this is sufficient for our answer. If you are asked to simplify it further, you could distribute the 5 to make it 5 square root of 5 plus 5 square root of 2 all over 3. But most of the time, we'll be able to leave it right here. If there are two terms on the bottom, multiply by the conjugate. Same stuff with the opposite sign in the middle. If it's just one term on the bottom, figure out what to multiply by that creates a perfect square or a perfect cube or whatever you're looking for, and multiply both top and bottom by it. Always look to see if there's reducing that can be done at the end.